Hello everyone, this is Rahul Shrestha here to present you the first part of the chapter Rest and Motion for Class 8. But before we start, let us just check out a short summary of this chapter and see what are we actually going to study here. So first, we'll be starting off with the topic Rest and Motion and understand how both of these terms relate to each other. Then we'll study about speed and velocity. We'll learn what is acceleration. We'll also read some equations of motions and learn how to use these equations for solving our numerical problems. And then at last, we'll learn about the relative motion of two or more objects. So this is everything that we are going to deal with in this chapter. Now let's start with our very first topic, which is rest and motion. See, every single object or organism, basically everything that exists in this universe at any given time, is in a position or state of its own. And this position can either be the position of rest or the position of motion with respect to its immediate surrounding. So if we look at this book, we can easily tell that this book is at the position of rest. And how did we say that its position is of rest? Basically, it's because this book is not changing its position with respect to this table or the ground or this vase, which are its immediate surrounding. And that is how we can say that the book is at rest. Literally speaking, rest is that state of an object in which it does not change its position with respect to the other objects of its surroundings, which means that in order to specify some object to be at rest, that object should not change its distance or direction from some reference point, at least for that moment of time. Here, the reference point can be any particular object in the immediate surrounding of that object. So as the book here is neither changing the distance nor the direction with the reference to the table and the vase, so we can say that it is at rest. And in the same manner, if we look at this boy, we can easily say that he is in motion, as he is constantly changing his position with respect to its surrounding. So an object can be said to be in the state of motion if it keeps changing its position with respect to a reference object in a given time. And in this case, as we can see that the boy is constantly changing its distance with respect to a reference, let's say this tree, we can say that he is in motion. Now understand that there is no object in this universe which is in the absolute state of rest or in the absolute state of motion. Basically, there is nothing such as absolute rest or absolute motion. If you look at this person, Ram, he is in a state of rest, as we can clearly see that he is not changing his position with respect to the other person, Shyam, who is sitting right beside him. And thus we can say that both of these persons are in the state of rest with respect to each other. So within this small frame of reference, both of them are at rest. But what if we expand this frame of reference and see the bigger picture? Now you can clearly see that both of these persons are actually sitting inside a bus which is in motion itself. So it means that if the bus is in motion, then both Ram and Shyam are in motion too. But not with respect to each other. Rather, with respect to someone, let's say Lakshman, who is standing outside the bus, or with respect to the whole world outside the bus. So here, you should understand that even if some object can be in a state of rest with respect to one reference point, that same object can also be in the state of motion with some other reference point at that very same time. And this also goes the other way around. Here, even though Ram was in the state of motion with respect to Lakshman, but he was always in the state of rest with respect to Shyam, as he never moved from beside him. And this is why I said that there is nothing which is at absolute rest or absolute motion. Because even if something like the book on a table can be at rest with respect to us, but it can still be in motion with respect to something which is outside of our world. As you already know that our earth is constantly moving, that is rotating and revolving. So suppose if there is somebody observing this book from the sun, then for him this book will always be in motion, as the earth is constantly in motion even if it might be at rest for us. And this is why both these words, which is rest and motion, are said to be relative terms, which means that in order to specify some object to be either at rest or at motion, we first need to relate that object to a particular reference point. So if in the previous case we relate Ram to Shyam and take him to be the reference point, then Ram is at rest. But now if at that same time we change his relation and relate Ram to Lakshman and take him to be the reference point, then Ram is in motion. Now, if a question is being asked, why rest and motion is called relative terms? The answer would be that in order to specify some object to be either at rest or motion, we first need to relate that object to a particular reference point. And an object can be at the state of rest in relation to one object, while it can also be in the state of motion in relation to another object at the same point of time. Now understand that whenever we say that an object is in motion, it means that the object is actually changing its position with the passage of time. So in this case, this car is moving from the position A to the position B in the time frame of 5 seconds. Now if the car is changing its position, it means that the car is actually covering some distance with the passage of time, which in this case is suppose 20 meters. Now this concept is what is called speed in science. If you look at the definition of speed, it is the distance covered per unit time. So speed is nothing but a simple ratio of the distance covered to the time taken to cover that distance. And because distance is measured in units of length such as meters, kilometers, miles, etc., and time in seconds and hours, etc., so some common units of speed are meters per second, kilometers per hour, miles per hour, etc., out of which meter per second is taken as the SI unit for measuring speed, as meter is the SI unit of length and second the SI unit of time. In our previous case, the distance covered by the car was 20 meters in the duration of 5 seconds. So we can say that the car was actually traveling at the speed of 20 meters divided by 5 seconds, which is 4 meters per second. And this is what is the speed of this car, which means that the car was moving a distance of 4 meters in every passing second. Now, a lot of times you might have heard people talk about speed in their conversations, that he or she rode a bike at the speed of 80 kilometers per hour, or he was running at the speed of 5 miles per hour. So here, this 50 kilometers per hour of speed tells us that if a person starts just from now at a constant speed of 80 kilometers per hour, he would cover the exact distance of 80 kilometers with the completion of 1 hour. Or in other words, he will move a distance of 80 kilometers away from this point of origin after 1 hour is completed. And if he continues to move at the same constant speed, then he would cover a distance of more 80 kilometers again in the second hour, covering a total distance of 160 kilometers within 2 hours of time duration. Now motion basically is of two types, uniform motion and non-uniform motion. A motion in which an object covers equal distance in equal amount of time is known as uniform motion. If suppose this boy covers a distance of 10 meters in 5 seconds from A to B, then again he covers the next 10 meters in the next 5 seconds from B to C. Here you can see that the boy is covering an equal distance of 10 meters in every 5 seconds of time duration. You can also see that if we find out the speed of this boy at every single transition from A to B and B to C, it is constant as well, which is at 2 meters per second. So this type of motion is called as uniform motion, in which equal distances are covered in equal amount of time, or the motion in which the speed of the object remains constant can be termed as uniform motion, which in this case is 2 meters per second. But generally, things don't always move with a constant speed, but rather with variable speed which changes from time to time. Except for the celestial bodies like planets and satellites, most of the other things move with a non-constant speed. Think about yourselves. Do you think that you always move with the same speed every time? Definitely no. Sometimes you walk lazily, sometimes you walk hastily, and sometimes you run. So your speed changes every time depending on how you are walking or running. In that same manner, all the vehicles in the road also change their speed time to time. So this type of motion in which the speed changes from time to time is known as non-uniform motion. It is a type of motion in which unequal distances are covered in equal amount of time. In our previous case, if suppose the boy after moving 10 meters in the first 5 seconds would have moved 20 meters in the next 5 seconds, then this would be a non-uniform motion in which the speed is changing every single time, which in this case is 2 meters per second from A to B and 4 meters per second from B to C. Now, if suppose I ask you, what was the speed of the boy in the first case when he moved from A to C? You can easily give the answer to be 2 meters per second, as the boy is moving with a constant speed of 2 meters per second every single time. But if suppose I ask, what is the speed of the boy in the second case while he moved from A to C? Can you answer the question? Is it 2 meters per second or 4 meters per second? See, the thing is that non-uniform motions like this cannot be expressed by a single speed like these. As the speed is changing between 2 and 4 meters per second, and expressing either of the two speeds as the speed of the boy would be incorrect in this case. Instead, what we do is find out the average speed of the object, which is done by dividing the total distance covered by the total time taken to cover that distance. So in this case, the average speed will be total distance covered, which is 30 meters, divided by total time taken, which is 10 seconds, which give us the average speed to be 3 meters per second. So the answer to the above question is that the boy is moving with an average speed of 3 meters per second from the point A to point C. Remember that in order to express a non-uniform motion, we should always use average speed of that object instead of expressing its individual speed at different intervals of time. Now I hope you people might have understood all of the topics clearly. I'm done with today's class and we'll meet again in the next part of this chapter. Till then, take care and be safe. Thank you.